Okay, sorry I was a little bit late this morning. Let's get started. As usual, just a few housekeeping notes before we get started. Let's talk for a moment about Deliverable 2. First of all, my apologies. Things have changed quite a bit since 2 years ago when I taught this course, and it seems that not all Python libraries like each other anymore, so I apologize for that. How many of you have started in on Deliverable 2? How many of you have got MPL toolkits to work? A few, quite a few. Okay. I know some of you are having a challenge with Deliverable 2, and I have not yet been able to come up with a fix to it. So I am modifying Deliverable 2 a little bit. So because of that, I'm going to push back the submission deadline for Deliverable 2 by a week. So Deliverable 2 is not going to be due this coming Monday night. It's going to be due the following Monday night. For those of you that are making progress on Deliverable 2, go ahead and finish it up. You can submit it on time. Okay, so I am still in the process of rewriting Deliverable 2, and I will put that up as soon as I finish, which will hopefully be tonight, I'm hoping. When I put it up, what you will see is throughout Deliverable 2, starting at step 12, if you are not able to get MPL toolkits to work, you're going to continue on using matplotlib, which all of you have now got to work in Deliverable 1. So if you're continuing on with matplotlib, you're going to be following the green instructions. If you get to step 10 and 11 and you successfully get MPL toolkits to work, then you'll be continuing on using MPL toolkits and drawing things in 3D. For our purposes for this course, it doesn't actually matter whether you draw the hand in 2D or 3D, so not to worry if you can't get MPL toolkits to work. You're going to continue on drawing using matplotlib in 2D, otherwise MPL toolkits and drawing things in 3D. So if you do get MPL toolkits to work, you should, at the end of Deliverable 2, get something that looks like the following. So you'll have a three-dimensional volume, and you'll be drawing 20 lines inside of that three-dimensional volume. And if you do not get MPL toolkits to work, you are going to be drawing in 2D, as I mentioned, and you'll get something that looks like the following. And assuming there we go, okay. So you're still drawing in 2D, hopefully. Still got to work out a few of the kinks here. Definitely have to work out some of the kinks. Okay, I will get there. You could see the idea, right? So we're still drawing in 2D, but luckily your brain will adapt and interpret the two-dimensional drawing as a three-dimensional drawing. Won't matter too much. Okay? Straightforward? Okay. Back to the schedule. We're going to push back the deadline for Deliverable 2. So for those of you that are having problems with MPL toolkits, you got an extra week to work on it if you need it. But again, I want to try and keep us all on schedule. So I will talk about Deliverable 3 next Tuesday, and Deliverable 3 will still be due on schedule the following Monday. So hopefully by Monday, September 17th, we're all back on schedule. Sound good? Okay, again, my apologies. Thanks for bearing with us on this. Other housekeeping notes. Unfortunately, I will not be able to make my office hours today, which is Thursday. However, the TA will be able to make his office hours on Friday. If you're a Mac user and you need to talk to a Mac user, send me an email and I can try and help you out through email. Okay. Aside from installation headaches, any questions about Deliverable 2? No? Okay. Okay, so let's get back to lecture. We're going to finish our lecture today on PACT analysis. What does P, A, C, and T stand for? People doing activities in a context. And then once we understand the P and C and T, we can start to do T, which is the technology. Right, okay. So just as a little reminder as to where we were. Okay. So it sounds like kind of an obvious thing to do, but often the hardest part is the context. Where and when and how exactly are people carrying out these activities that influences our thinking about this. And last time we started to unpack the P and the A and the C. Of course, people are complex and differ in lots of different ways. We need to think about the technology we're creating. Does this support people that have physical differences, psychological differences, cultural differences, usage differences? They're novices or experts or power users. And then we ended last time by starting to unpack what we mean about an activity. So what exactly are the users doing with this technology? Or maybe they're already doing the activity without the technology and you're thinking about creating a technology to make that activity easier, faster, more social, what have you. There's lots of different ways we could start to break apart the activity, but the first 4 items that we were thinking about last time were these temporal aspects. How does an activity unfold over time? How regular and frequent is it? Is it smooth usage, or are there peaks and troughs in the number of people using it? Continuous versus interrupted. And we ended last time by thinking about if there's a task where people work on it a piece at a time, that influences the way we start to think about how to design the technology to support it. And in lecture 4, which will start in a few minutes, we're really going to start to focus on this issue of design. Okay, response time. How quickly does the software need to get an answer back? For certain tasks, that feedback has to be real time. Have you ever used a mouse where the cursor moves slightly out of it, it lags by even 1/10 of a second behind the movement of the mouse? It's maddening, right? Your brain has an expectation by now that when you move this thing on your desk, you should see something move on the screen in real time. If you break that expectation, you got a very frustrated user on your hands very quickly, right? In the old days, if you type something into a search query, you'd be able to wait a few seconds for it to give back an answer, but now again, our expectations are more or less real time. So what interaction are you creating with the user, and what sort of speed of response are they expecting? Okay, so that's sort of thinking about how the activity unfolds over time. What about cooperation, right? What's the social aspect of this? Is there going to be one person working on the activity, they stop, someone else comes and continues the activity? Are there more people working on it at once? Are there more or less people working at it at once? How does that influence the design of technology? I assume pretty much everybody here has worked with Google Docs or Overleaf, something where you're doing real-time document editing, possibly with other people in real time. Took a long time to get that right? So let's think about Google Docs for a minute. What are some of the design choices that have been made there, given the fact that people are editing a document together at the same time?
And revision history for every version.
Revision history, that's important, but if you think about it, revision history is still useful even if I make some changes to the document, I leave, you come and make some further changes, you want to see the changes that I made, so you check the revision history. Revision history is useful, but it's not necessarily paying attention to the fact that people are working on it together in real time. Yes? Color coordination, right? So anonymous crocodile or whatever it is on Google Docs.
They hide a lot of the more complex features in the menu, so they promote just plain text typing.
Okay, so again, as Google's start was always about the KISS principle, keep it simple. So a lot of the complex stuff is hidden. You see the text, you see different colors. What else do you see?
You can see everyone's cursor.
You can see everybody's cursor, right? So very simply, without a manual describing what this red vertical line is in the text, I know what it is. That's not my color. That's someone else's cursor. And if someone is there moving, if the cursor is there, what that actually means is someone has actually been editing or moving the cursor within the last few seconds. I don't know how long it is. If you're idle in Google Docs for a few seconds or about a minute, your cursor will disappear from the view of the other people that are viewing the document at that time, right? So the cursor is actually not just showing you that there's someone else there, but there's been someone else there recently, so back to the temporal aspect of it, and where they are in the document, right? So without putting too much information in addition to the text, there's a subtle clue there for you about who's here, where are they, and when was the last time they did something in the document, right? Pretty subtle, but it took a fair bit of thinking to get that all right. There were some earlier ideas that didn't work out so well. Okay. The task itself, how complex is it, or sort of how well defined or vague is it, right? So we would like to create a document editor where multiple people at different computers can edit the document together in real time, right? That's a pretty specific definition of the task. There are other tasks where it's a little bit more vague. It's a little bit hard to get the potential users to describe what they would like to do, what they would like to do together. And again, we're going to talk about design in a few minutes. And our understanding of the task is going to influence how we go about designing the first few prototypes. Perhaps if we have a pretty sharp definition from our users, we can turn that into written requirements and then sit down and sort of code things up, a sequence of prototypes one after the other. Or the users can't articulate to us what the task is, so we'll make some prototype, throw it out to our alpha users, our beta users, sort of see what happens. They learn something, we learn something, we scrap the prototype, we make something completely different, we sort of explore the space, right? So the prototypes are not necessarily steps toward the final product. They're tools to help all of us articulate exactly what are the P's and the A's and the C's within this space. Okay, safety, we mentioned this with the cobots. This one is kind of obvious. If you have a physical machine that weighs 1.2 tons and it's going to be moving right next to someone, either a cobot or possibly an autonomous car, safety is an obvious thing to think about. But obviously our world is becoming more and more interconnected, and you may be writing an app for a phone that clearly has no safety concerns, but when you put it in the ecosystem of other apps and phones, and someone's going to be looking at your app on their phone while they're performing some activity in a context, there may actually be some safety considerations to think about. It's not always so obvious to see whether a piece of technology requires some thinking about safety or not. While we're on the topic of safety, I think it's always worthwhile remembering the case of the Therac 25. This was unfortunately the worst software bug in history. So the Therac 25 was a medical device back in the 80s, and it was used to irradiate cancerous tumors with a cloud of X-rays. And the idea here is obviously we want to try and irradiate a cancerous tumor from a patient. We want to make sure that the X-rays hit just the tumor and nothing else. We want to localize this as much as possible. But you cannot irradiate a tumor with a direct X-ray beam. It is too strong and will cause harm to the patient. So in the 80s, there were these series of devices where they would move this X-ray shield, which was basically a block of lead, would move it into a particular position between the patient lying on a table and the electron gun that is going to send out the X-ray beam. The beam would hit the lead block, pass through the lead block, and from the far end of the lead block, put out just the right cloud of X-rays to irradiate just the tumor. So there was some software to control the Therac 25 that would move, given the patient and where the tumor is, would move these shields just into the right position, and then move the electron gun into position, then fire, and off you go. Okay. Unfortunately, what happened in the Therac 25 is the software would send commands to move the shields. Obviously, you want to move the lead blocks before you turn on the electron gun, which is what happened. The shields, commands were sent to move the shields first, and then commands were sent to fire the gun. But there was a race condition in this situation, which is we're moving shields, and there was a vague specification of exactly how fast these shields would move. And unfortunately, these shields had not yet moved into position before the gun was turned on. So there's a very short period for many patients where they were directly irradiated by the gun before the shield moved into position. Why did this happen? It happened because before the Therac 25, there was a system called the Therac 20. And in that case, in the Therac 20, the shields actually moved more quickly. So in the Therac 20, commands were sent to move the shields moved into position, then the gun fired, then the commands were sent to the gun, and then the gun fired, everything worked fine. When they moved to the Therac 25, the movement of the shields was different, and that subtle point was missed, which led to this problem, right? So again, this is not really about HCI, but again, we need to think very, very carefully about safety. For those of you that are interested in the history of computer science, it's very interesting to read up on this unfortunate situation. Okay. Is your system safety critical? Is there actually the danger of actual damage or death? We need to think carefully about that. Lots of feedback, explicit timing, and so on. Maybe your system isn't going to cause direct physical harm to a user, but the system might make mistakes, or users might make mistakes. How are you going to handle mistakes, errors, and omissions? For example, are you going to take a proactive approach? So if the user does something, the system might say, are you sure this is what you meant? Are you sure you want me to do X? Proactively ask, interrogate the user before performing the action, or retroactively get the feedback from the user, do what the user asked, and if the user said, hey, something went wrong, then correct things. Depends on the P and the A and the C whether we decide to go forward with a proactive or a retroactive approach to safety. Okay, once we've sort of gone through all these activities, now we might start to move over to the T and start to think about the technology. Given all of these issues, for example, what is the kind of data that's involved in our system? We're going to focus on the interface, so we're broadcasting some sort of information back to the user. If we're focusing just on visual for a moment, are we going to do things using streamy data or chunky data? And we're going to talk about this again when we get to cognitive psychology. The human visual system deals with video and icons very differently. For example, streamy is very good. You've probably been in a classroom where someone in the front row is watching an awesome video on YouTube, and you're trying diligently to pay attention to the professor, but your eyes keep saccading or jumping to the cool video that your fellow student is watching on YouTube in the front row, right? Even though you don't want to, video tends to attract your attention, right? You can try and pay attention to what I'm saying, but you also cannot fail to attend to this thing that's going on over here, right? Things that are continuously moving or making a sound, like video or speech, our brains naturally attach to, and it becomes harder to pay attention to things that are not moving and persistent. So chunky is an image or icons or text that is not moving. There's pros and cons to these. What's the pro and con of presenting information in a streamy manner or a chunky manner?
Chunky means that you don't have to constantly be sending and receiving data, so you can instead load the blocks that you need when you need them.
Okay, so thinking about the technology and what it can do or can't do, we can make things easier on the T, the technology, by presenting something and then not have to be continuously loading information. That may be important if we're trying to present information to a remote device that somebody has that's relatively far from a Wi-Fi tower. It's hard to get data. Maybe we want to do things in a chunky manner.
Streaming can be good because of what you said, like it really catches your attention. Like we all hate video ads, but that's like a really good way to like kind of force people to pay attention to your advertising.
Absolutely, right? So you can be sure that if you're streaming something, you can sort of grab attention for a while, which is a pro. So if you're an advertiser, that's great. I record these videos, and hopefully watching the video, it's easier for you to pay attention for the 75 minutes of the video.
Not all streaming is video and speech, but a lot of it is very interactive. Like someone can respond to you, and then you can respond to them in real time.
Absolutely, right? So you can have a real-time interaction in some cases with streaming systems, not so much with chunky.
Chunky things are available for review.
Chunky things are available for review, right? So while we're having this discussion, if you've already forgotten the 4 temporal aspects, they're up there. You can watch them, right? If you were to just watch a video lecture of me going through these 10 aspects of an activity without recourse to the chunky text of the slide, you'd have to remember, right? So streaming puts a load on your memory. You need to remember because literally what was shown in this frame is gone in the next frame. So chunky things are persistent, but streamy things are attractive, right? They attract your attention. Pros and cons. Depends on what the task is, right? Some people might choose streamy because streaming is very popular at the moment and we want to focus on what the technology can do, but that might not be the right choice for what the person is trying to do, what the user is trying to do. Okay, we're going to talk a fair bit about visual design in this course, assuming you're trying to create this interaction with the user. What do you need to present to them? We just talked about 2D and 3D, the pros and cons there, how to display data, text, motion, sound, all these issues. Visual design is actually a relatively complicated endeavor, and we're going to talk about it shortly. Okay, so again, here's a list of 10 aspects of an activity that you might start to think about. This 10th one is not really about, 9 and 10 is not really about the activity, but it's sort of taking the activity and starting to think about the technology. There's different ways we can break this up. One of the take-home messages for this slide is that there are lots of aspects of an activity we need to keep in mind when we're designing interactive technology. Okay. Okay, so we talked a little bit, we tried to unpack people and unpack activities. What about context? This is also often the most challenging one because a lot of the context of an activity is unspoken, subtle, not obvious to begin with. First aspect of a context is where. What is the physical environment? Is the technology going to be used indoors or outdoors or both? What are sort of the noise levels that you can expect when the person is interacting with the technology? Does that matter? Maybe yes. Are there going to be a lot of people around? Is there going to be more than one person looking at the screen in addition to the user? Is this a private or public interaction? What about internet access? What can you assume in terms of speed? Does it matter whether your system has a relatively slow connection or a fast connection? If you've decided you're going to stream content, then obviously you better hope that most of the time your technology is being accessed with a good internet connection. Physical things obviously are relatively obvious. You can sort of figure those out just by talking to the people and thinking about the activity. Social context, maybe yes, maybe no. How many people are going to be using it? What is the distribution of expertise among the people that are using it? Sound output, for example. If there are going to be a lot of people, might make sense not to allow sound output in an open plan office or give the option to mute. And if I mute, is there closed captioning or can we somehow, is there some way to convert the audio to video if you're in an open plan office, for example, but in a cubicle or a closed office? That's fine, depends. Again, you might just build in options so people can set those options as they like. Then there's sort of organizational context or cultural context. What are sort of the unspoken rules of the group that are going to be using it? So now we're getting beyond just the user and starting to think about everyone else in the open plan office or everybody else in the company or the society and so on. So if you create the next killer app for smartphones, there's a very good chance that it might actually impact the structure of companies, universities, schools, cultures, laws, nations, social institutions. There's been half a dozen examples of that in the last year. What are some examples?
Wait, in the last year?
Let's say, yes, let's make this fun. The last year or so. What are some...
Facebook.
Facebook, yes. What about Facebook? Facebook's been around for more than a year.
The ability of users to create content that isn't trustworthy.
Okay, you're right. So certain users may create content that's not trustworthy. Again, that's kind of been known for quite a while, but suddenly people have realized that this actually has political repercussions, right? And for this particular country, pretty big ones, given the culture of this particular country, right?
Amazon has like allowed their users to create their own businesses.
Okay, yep, that's a great example. We mentioned last time sort of lowering the barrier to entry is one important aspect of HCI, right? Empowering individuals, creating your own company. You can create your own company or sell things through Amazon or Etsy, or just create your own website and collect money and send products and services to people over the web. How is the government going to tax that company? Right? There are all these issues now, which just now in the last few years, the law and the political system have woken up to, right? There are these very unexpected legal and political repercussions of the fact that technology and social media in particular are sort of restructuring society.
I know Twitter's sort of transformed into a little bit of a political platform.
Okay?
It's been really interesting, and also there's been like a couple attempted drone terrorist strikes, which has been really interesting.
Absolutely. We mentioned
So
that last
from
time.
like a hobbyist thing to something where it's now a security issue.
Absolutely, right? So now there are security issues around drones and other kinds of technology.
I think it's been around for a little over a year, but
Yeah.
Stack Exchange pretty recently started like hiring programmers through their like interface. So like companies can like look at people who post good things on Stack Overflow and hire them through that.
Absolutely, right? So affecting companies, right? The ways in which companies hire employees is really changing, right? Used to be you did well at university and you got a job. These days you've got to demonstrate your skills if you're a coder on those coding challenges websites or through Stack Exchange, right? You got to demonstrate or perform in order to become employed rather than just do well at school. That's definitely a big social change that some of you may be interested in.
Bitcoin exploded.
Absolutely, right? Bitcoin also has an environmental impact, which seems strange, right? It's a financial currency thing, but now recently there's a realization that this might also have an impact on the environment. How so? No one saw that one coming, for sure.
Energy usage to mine them.
Energy usage, right? Mining Bitcoin, the more nodes, the more cores you can get, the more you can mine Bitcoins, and so energy usage is definitely going up in terms of high-performance computing facilities. Okay, the disruptive nature of technology, this has been around for a long time, right? Technology definitely puts people out of work, but also creates new kinds of jobs, right? So this last aspect here is sort of thinking about all these disruptive aspects of technology. We should all be so lucky to create a killer app that's killer enough that it actually disrupts technology. It does happen. Okay. Okay, so finally we get from P and A and C to T, and now we need to start to think about technology. Again, in this class, we're not going to focus too much on the internals of your technology. We're really focusing on the front end, right? The part of the code that is interfacing with the user, the input side of things, the output side of things, and communication. So on the input side of your technology, what is coming in? What do you need to collect from the user, from stakeholders? What sensors do you need on your system to pull information directly from the physical world? How much, how often? We talked right at the beginning of this course about the number of input devices. The Leap Motion device uses probably a novel input channel that you might not have experienced before. And as you're discovering in the deliverables, that influences the way you think about writing code for Leap Motion. So Leap Motion is collecting input in real time. So we have this while true loop going all the time, rather than passively waiting for the user to press keyboard buttons or move the mouse. It's real time. And the kind of information that's coming in is a little different, right? It's not key presses or movements of the mouse. It's 3D coordinates for bones in the hand. Very different. And it influences the way we think about things. Is your system going to be able to exploit its input? Is your system going to be able to exploit its input devices using its output devices? Can your system move or push against the world in some way to influence the way in which the world pushes back? We talked about the differences between people and machines at the beginning of this course. This is something that humans do all the time. I can't see everyone in the class, so from time to time I move to change who's occluding who, right? Most machines at the moment are passive and cannot do this, right? Your leap motion device can't move itself to track your hand. It's got to hope that you keep your hand over the device, but that's changing. What are some examples of technologies that are emerging that can do this, that are active? They can move or push against the world to broaden or change the kind of input they draw. Self-driving cars, the most obvious example, drones.
There's this new thing that's coming out. It's kind of like a startup where you can connect little propellers to your phone.
Okay.
And you can like set a timed selfie and
Okay.
let go of your phone, and it will like float and adjust to like get a good picture.
I've seen that, right? Thank goodness we all lived long enough to see flying phones. It's an amazing time to be alive, right? It's just the beginning. Okay. Great example. All right. And then we already just talked about output, right? How are you presenting information back to the user? An important aspect of output, or the interaction in general, is coming back to an idea we're going to touch on again and again in this course, which is that the human brain is a prediction machine, right? So it should be presenting something that is reminding me that the system is supporting my intuitions or not. So if I have my flying phone that's trying to take a selfie, I expect that if I move a little bit, it should move and keep me in the frame, right? Its movement is also helping it take the selfie, but its movement might also be indicating to me, I see you, or I see your face, and I'm tracking your face, right? So the output of any technology is also trying to help the user say, I know, I understand, or I need more information, or I need you to do X or Y. Okay. And then, obviously, the technology itself, does it need to be communicating with what other technologies? How is it communicating? Does it need to alert the user that it's doing so? Do I know that my phone is talking to other phones or talking to the internet? Do I know that my phone recognizes not just my face in the selfie, but recognizes the other faces of the people behind me that I may or may not know are there? Communication is important. Okay. And then finally, the internals. What data is contained within the system? What data is shared? How many software components? How are they connected? What algorithms are employed? That's all software engineering, right? We're not going to talk too much about that in this course. What we are going to talk about is how visible does the system make its internals? Does the user need to know these details? There are cases for certain technologies where the technology does need to broadcast what's going on inside, given the person and given the activity. What are some examples of that? Most of the time, we like technology that's kind of quiet about what's going on inside and just helps us with the task. But from time to time, tech says, wait a second, there's something going on inside that you need to know about. Absolutely. We may decide that we want to get into the lower levels of the system, but where are the cases where the system decides that we need to know? Again, we might decide, but what are the tasks or activities or the user group where the system says the user needs to know the following?
When like my phone has water inside its ports, it says water detected, don't charge your phone.
Okay, absolutely, yeah.
When you install a program, it always tells you where it's being installed.
Absolutely, right? Which, for those of you that are having installation issues, this is really important, right? Where's my Python? Where's my matplotlib? Where's my leap.py? Most of the time, that doesn't matter. Unfortunately for you guys, in the next 2 weeks, it does matter, right? And as you probably figured out, most of the time, those dirty details are hidden from you for good reason. But for the next few weeks, we're power users, and we need to know that information. Right? Your system, your platform may or may not know that you need to know that and present that. So think about, and maybe it's hard to think of examples now, but they're coming, about adaptive systems, where most of the time it's hiding all the details, but the system is inferring some kind of interaction is going on, and it gives you more information. It says, I see the user is frustrated or confused or needs to get down into lower levels of the operation stack. Here's what's going on. Okay. For our purposes, we're going to assume most of this is invisible for most users and most activities. Okay, so just coming back to this example about thinking about tasks and thinking about data and communication, there was a task that came up in the last 10 or 20 years where people wanted to share very, very large pieces of data. So you had a whole bunch of people connected through the internet. One person had a copy of that very large piece of data, and everybody else wanted it. So what happened? Stolen, maybe. I haven't said anything about whether this large piece of data is legal or illegal. I have it, none of the rest of you have it.
Well, one person gets it, and then two people have it, so like two people can grab it from different.
Okay, so I have it, you want it, you connect to me, and you start drawing the entire file to you, which ties up my output channel, and the rest of you have to wait until you have a copy, and now there's 2 copies, and now you can try and ping one of us and hopefully get the entire copy from one of us. Not very efficient, right? Doesn't work very well. So there was a realization that the situation existed. Suddenly, one person had a very, very large file and no one else had any of it. And how do you best distribute it? The torrent algorithm came along, which chops up the piece. So rather than giving the entire file to you, which is going to take a while, I'll give you 10% of what I have and a separate 10% to you and a separate 10% to you, and then you start broadcasting your 10%, you broadcast your 10%, you broadcast your 10%, right? So this idea of actually chopping up a file and uploading just a fraction of it was pretty radical at the time, right? Why would you ever upload just 10% or a small piece of a file, right? But obviously it starts to make sense because now we switch to a system where there isn't just one server, the person that has the entire thing, and everybody else is clients. We're going to try and erase that distinction so that as quickly as possible, everybody becomes clients and servers, right? This distributed nature of sharing content, probably to most of you that just seems blindingly obvious, but just a few years ago it wasn't that obvious, right? There was this specific situation, one person had a big file, nobody else had a copy of it, and off you go. Okay, that's the technical side of it. The cultural side of it, of course, is what is that big file that I have? Something that's probably illegal, right? So then there's the whole political and legal aspect of the torrent systems, which is, again, another interesting conversation to have. We're just focusing on the moment on this activity, which didn't really exist until suddenly it was relatively easy to steal a movie or a song or what have you, and then how do we support that activity? Okay, so we're going to end lecture 3 here by playing this game we played briefly before, which is I'm giving you a P and A and C, or 2 P's and A's and C's, two hypotheses here, 2 different scenarios. And I want you to sketch out, by turning to your neighbor, just very quickly a few sentences or a sort of high-level description of a technology that would support that P and A and C. And let's see what you came up with. And then, as you can probably imagine, we're going to do it all again, and I'm going to change the context on you. And we're going to see how you're thinking about T changes. So turn to your neighbor, pick one of the 2, and start to sketch out, given this discussion of aspects of technology, what aspects of the technology are important for that particular user group, activity, and context. Go ahead, I'll give you a few minutes for that.
The context of them are
It's up to you. You just assume what you want. Good question. Yes. Ah, it's not specified. So that's a good question. You can assume either. It could be from the store or a different store. I mentioned a mall, so think about activities in a mall. Right? Okay, we could probably spend all day on this. Let's see what you came up with. And before I ask for some ideas about technology, there are a couple questions here at the front about the context. So is the person walking by, did they just come out of the store and they're carrying a bag from the store? So do they just finish shopping in the store? Is it a shopping bag from another store? Does it matter? Those are all good questions. They're questions about the context and the activity, right? So these are sort of, it's not even specifications, it's just kind of a sketch of this situation, and clearly it's very vague. And my answers to your questions about that are going to probably influence your thinking about the technology. If you're the owner of the store, do you want to be recognizing bags from the store itself or from other stores? Other stores, why? It's kind of obvious, right?
You have the ledger of what was purchased at your store.
Right. You've already extracted some money from this person. Why bother trying again, right? Okay, so some of these things you can already start to infer by yourself, right? We've got a bunch of stores together in a mall. Okay, let's start with number one here. What are some aspects of the technology? How has P and A and C influenced your thinking about this technology?
Well, first of all, people are going to walk by the store in two directions. It might be right or left-handed.
Okay.
So you need a sensor in front of your store and a sensor across the street.
Aha, okay, so right, so some people are lefties, some are righties, maybe they got lots of bags, one in one hand and the other, they're coming from the right or the left, maybe it matters. So we may need a sensor on the storefront and a sensor across the road or across where they're walking, which may be tricky depending on the context, right? My competitor store right across the way from me is probably not going to agree to put a sensor that's going to help you advertise your product. So already now we're talking about issues that go beyond just the store itself.
There would have to be some sort of agreement on group stores sharing this information, because you can't just like have a camera look at a bag and know everything's in it. There has to be some sort of like RFID chip or something on the items, and if another store is letting you scan their RFID chips, then you will probably have to do the same for that. So there's going to be some sort of addition to your products so that other stores can do the same benefit that you're getting.
That's a great point, right? So we're scanning this bag. I didn't say anything about or how do we go about scanning this bag, right? So with a camera, we probably can't infer what's in the bag, or can we? Or do we just decide it's easier to put an RFID tag in the bag? And if so, then maybe we need to get together all the store owners in the mall and decide some sort of a non-compete clause where we're all going to agree to put RFID tags in our bags and we can all advertise collectively, right? It depends. Perhaps that agreement breaks down, so I do have to resort to using some computer vision algorithms to try and recognize the logo on the bag and make some educated guesses about what's in the bag. What are some pros and cons of these two design choices? RFID tag versus computer vision. What is an RFID tag, first of all, for those that don't know?
It's a small, pretty sure, like non-electronic. It doesn't have any actual charge in it, right? It's just a.
It is electronic, but it has no battery in it.
Right.
So radio frequency ID tag.
Yeah, and it just can respond. You can detect it with the radio frequency.
Absolutely. So if you send out radio waves, if you hit it with radio waves, that provides enough energy to charge the electronics and do a very small, short, brief task, right? So there's no battery, there's no onboard power, which means you can make RFID tags very, very small. You can put them on shopping bags. You can possibly surgically implant them under the skin, which we'll come back to at the end of this course. Okay. RFID tags on shopping bags versus computer vision. What's the pros and
I would
cons?
say the tags are really specific and accurate,
Okay.
but I guess they would limit it to just the types of bags. If you had a camera, you could theoretically sense if someone is like pushing a stroller, for example.
Okay.
You could advertise them. I mean, it just depends. I guess it would limit it to just the bags, but if you use the camera, you could, in theory, expand it past the bags.
Absolutely, right? So as George Orwell and Big Brother reminded us, the possibilities are endless, right? So if I have a camera, maybe I can infer things not just about the bag, but that someone is pushing a stroller, and that might influence the kind of advertisements that I send out. Yep. Sorry. Yep, you? Yep.
Am I be considering invasion of privacy to see what's in the bag?
Privacy, of course, right? Yeah, exactly. Should we limit that? Who might be carrying the bag, which might also influence our issues about privacy? What else? I mentioned before when we were unpacking P and A and C that C is particularly tricky, context. What are some of the unspoken contexts that matter in this particular scenario?
If it's a minor, you can record them without their permission.
If it's a minor, right? And who do you tend to find in malls these days? Minors. Okay, so the RFID tag is actually a pro because if someone buys something in the store, we might check their ID. If they're over 18, we give them a bag with an RFID tag in it. If they're under 18, they get a bag without an RFID tag. And we have some legal oversight. We're reporting to a higher authority that we are actually doing this, and we might be able to comply with limited advertising to minors, right? Assuming that's an issue. So there's something that, at least on a first pass, doesn't immediately occur to everyone. And then once you realize that, then you start thinking about the technology. If you're not going to go with the RFID solution, you're going to do everything through computer vision. Your computer vision algorithm better be pretty good about predicting the age of the person carrying the bag, or you might be in some regulatory hot water.
It occurs to me that once people realize that you're reading what they're buying and displaying it to a screen, first of all, that's not great. If someone broadcasts exactly what you bought to the rest of the world on the street, they're gonna start hiding the bags. And so if you're using computer vision, they might try to shift it behind your body.
Possibly. Yep.
Or if you're using RFID, people are gonna start shopping with RFID safe bags.
Ah,
They're
interesting.
shopping.
There you go. I'm going to put my bag in a bigger bag. That
Exactly.
absolutely, possibly. Who knows, right? So again, there is a context here, which is the person carrying the bag going to like this or not, right? Again, there's someone shopping in a mall, so maybe they just bought something and they see an ad says, oh yeah, I didn't think about that. Now that I bought this, I also need that or not, right? Are the people that are in a mall going to be privacy averse or not?
Well, I think there's something to be said about the people that be shopping in a mall. You can buy things online fairly easily now, so I think it's fair to say that people who are shopping in the mall are probably going to frequent that mall or be frequent customers. So I don't think necessarily changing the content real time might be like the winning solution for a storefront, but maybe collecting that data in one of the other prescribed ways and then changing it like daily to
Okay.
then like measure the average customer that goes by and see what they're generally buying.
That's a great point. So just to show you how fast technology is changing, the very concept of a mall is becoming slightly old-fashioned, right? But they still do exist, and people still do frequent them. And who exactly is still shopping in a mall? They may be a regular customer, right? It may be minors and seniors who are in the mall, right? It may be repeat customers, and that might influence your thinking about it. Okay, in the interest of time, we're going to skip over number 2 here, and I'm going to change the context on you. We covered this already now, which is I've now made it very explicit that we need to deal with minors. In the second situation here, instead of deploying wireless sensors just in the rainforest, we want to specifically deploy the sensors in a rainforest canopy to measure environmental variables over a 2-year period. Take 2 minutes, turn back to your partner, and talk about how you're thinking about these technologies change, given this change in context.
But if they're wireless, maybe we can see
And then just like this,
Okay, sorry, there's not a lot of time, but I want to move on. How did your thinking about T change when I changed C on here?
We had a hard time figuring out, we were doing number 2.
Okay.
We had a hard time figuring out how to power something that's on the ground for 2 years.
Okay.
But if something is in the canopy of a rainforest, it has access to sunlight.
Okay.
So we don't have to depend as much on large batteries, and so the devices can be a little bit smaller.
Great example. So let's focus on number 2 for a moment. So the issue of power, right? It may be actually easier to power a wireless sensor if it's in the canopy than it is on the ground, because if you know something about the physical context of rainforests, they tend to provide 100% shade on the ground. So if you have a solar-powered wireless sensor, it's probably going to not work well unless it's near the top of the rainforest canopy. So putting a device in the canopy might make things easier from a power point of view. What are some other challenges that arise? What are some of the drawbacks or the additional challenges?
Monkeys live up there.
Monkeys live up there. Absolutely they do. Why would that matter? Why might that matter? They throw things. Are they going to throw things at a wireless sensor?
They're going to throw a wireless sensor.
They might throw the wireless sensor, but they're probably not going to find them, right? They're small, the canopy is huge. So this is an example I drew from an actual real life situation, which, thank you for mentioning the monkeys, actually does have to do with that. Why might a small wireless sensor be found in the vast expanse of a rainforest canopy?
Well, I was going to say you're only going to be getting data probably from the canopy then and not the rest of the ecosystem below.
Okay, so of course if we put it in the canopy, we're only collecting information from the canopy. We're focusing here on context, right? We're trying to make things that are not immediately obvious unless you're a rainforest botanist or a biologist. What's going on in the canopy that might make things challenging? And yes, it has to do with monkeys.
Well, it has to do with my thing. It has
Okay.
to do with the sensors. So
Okay.
they usually have some sort of LED or flashing lights and power, and that would attract wildlife to it.
Absolutely, right? We're getting closer now. LEDs, right? You might need to flash something. There may be inspectors that are coming through underneath, and they're looking up at the canopy and looking for green lights, or sorry, they're looking for red lights, and if they see a red light, then they go up and fix things and so on. Might not be a good idea.
I mean, you have to deploy them in some way, and that would definitely attract interest at the time.
Absolutely.
And there is from that.
That's true, right? So maybe exactly monkeys tend to, including these monkeys in this room, where primates tend to be very curious, right? So absolutely. But that wasn't the problem. They were deployed just fine. The LEDs didn't work very well, so they got rid of the LEDs. And the damn monkeys kept finding these devices. How? Think about context here.
Do they have like an ultrasonic line that they had when they were powered on?
Good question, but no, it wasn't the sound.
Is it like what they're made of?
What they're made of, right? What are most electronics made in? They're usually put in a metal shell. Probably is waterproof in this case, but most of them are shiny, right? And if you're a primate running around in the canopy and you see sort of round things that are about this big that are shiny, from a primate's point of view, those things are usually good to eat, right? Okay, so again, this was not immediately obvious until they were actually deployed, and it might seem like a kind of silly example, but HCI is littered with these examples of, in retrospect, certain things are obvious. If you're going to deploy wireless sensors in the rainforest canopy, make them look as little like fruit as possible. Okay.
Yeah.
Okay, so let's move on now. That completes our lecture on PACT analysis. We're going to move on to theme number 2 now, which is this idea of design. So now that we know to think very carefully about P and A and C, how do we actually sit down and start designing things? What exactly is this process? We're going to start by talking about design philosophy and process, and then get into more specific aspects of design that apply to HCI. Okay. Oops. Okay, so design is philosophy, design is process. What is design in general? The design is always a transformation. It's a mapping from something to something else. It is usually a mapping from a need, a desired function, a frustration, some human emotion. Humans want to do something. And how do we take that need, which is often ill-defined, and a big aspect of design is describing precisely what that need or desired function is, and turning it into a physical structure or process. And in our case, it's going to be turning it into hardware, software, interfaces, and algorithms. Okay. So we want to try and perform this transformation in the best way possible. But what do we mean by best? And that's where design philosophy comes in. I might have a particular design philosophy about the best way to go about coming up with this translation. You may have a different philosophy. You might look at the exact same need and think about this transformation in a completely different way. You have a different idea about what's the best way to do it. The way to do it, the actual way we come up with, is the process, the design process. So we're going to distinguish now between design philosophy. I have an idea about how to come up with design processes, and then we're going to talk about design processes themselves. Okay. To illustrate the difference between design philosophy and process, and to really focus in on those aspects of design that are important for us in HCI, we're going to walk through design in a bunch of different domains, and we're going to do it in a particular way. We're going to start with design in very, very subjective spaces, like art and visual design, and we're going to gradually move from more and more subjective domains to more and more objective domains, which some of us are more comfortable with, which is technology, code, and so on. And what you're going to see as we go, and when we finally get to interface design, yet another thing that makes HCI distinct from a lot of other aspects of computer science is it is a mixture of the subjective and the objective. You can objectively write a piece of code that is as efficient as it can possibly be, and nobody wants to use it because they don't like it. There's something about it that's off-putting, right? It's subjective. So in HCI, we're trying to draw from both camps. How do people go about designing or making things that are appealing to people? How do people create art? How do people create great visualizations? How does architecture occur? How do you write a beautiful English sentence? Okay? These middle ones here are some mixture of subjective and objective, and less when we get down here. Okay. I am not an expert on art history or art, but I think all of us can probably pick out what are some of the principles of beauty. You might not say that someone actually designs a great work of art, that very word or that very verb design doesn't really apply in this case, but people do create works of art. You're translating a need or desire into a thing. What are some of the principles that artists tend to use during this transformation as they go about creating a work of art?
One of the biggest principles that I learned was always composition. Like you have a few rules of composition, and they follow those, and then your piece will look better.
Okay, so a few rules of composition. What do you mean by composition here?
Composition is just generally how you lay out the drawing. So
Okay.
it's like the rule of thirds, which means that you just split them in 3 sections.
Okay.
Or like the Fibonacci spirals, but it's pillars.
Absolutely. So a common underpinning for most Western art is the rule of thirds, right? Sort of balance or proportion. What are some other principles that apply? Perspective, right? So if you look at some representative examples here, some of them clearly try and draw on our intuitions about perspective, what you expect to see if you look at a human figure from a particular point of view. Other artists have a very different design philosophy and go about opposing principles, which are let's try and confound your predictions about perspective, right? This tends to be very confusing, as does this one for the human visual system. It's confounding your expectations, your brain's expectations about what it's going to see when your eyes move from one part of the painting to the other. What are some other principles of art that artists tend to follow in this transformation? Symmetry, right? Absolutely. So some of the works of art here are symmetric, and some are intentionally breaking that rule. Okay. Again, we don't need to copy these down, but here are some things that often artists keep in mind when they're trying to create a work of art. Balance, we mentioned that. Symmetry, proportion, color, originality, try and paint or make something that's never been seen before. Sometimes it's the opposite. Make something that resembles as close as possible to something we see in the natural world. Visual impact, perspective. In some cases, in the Western medieval tradition, it was to try and maximize ornamentation, the Baroque period, right? Put as many visual bells and whistles on something as possible. Within art, obviously, there are a lot of different design philosophies, ways to go about fulfilling the need that humans have to see something or contemplate something that is beautiful. Okay, very subjective. So let's move away from aesthetic design or artistic design to visual design, and we've already seen a little bit of this already when we looked at Gapminder. So we can argue about whether Gapminder is a work of art, but again, it tries to present something in a visually appealing way. Not that different from what we just talked about in terms of art. What are some of the principles here, the design principles that tend to be followed in Gapminder in particular, or presenting information visually? What are some rules of thumb that are good to keep in mind?
Like the closest stuff to us is the most recent, like closest to us in time.
Absolutely, right? So we mentioned this visual metaphor where things that are not occluded tend to be, we expect them to be closer to us, in this case, metaphorically closer to us in time, right? So a rule of thumb might be support people's visual intuitions. You may not want to follow in the tradition of these artists in visual design where you're explicitly trying to confound your intuitions. In art, that may work for some people. In visual design, usually not. If I want to think about something and be challenged by a visual representation, I'll go look at M.C. Escher's work. If I'm looking at Gapminder, there's something I'm trying to get done or understand something. Don't make it hard for me, make it easy for me, right? What are some of the other principles of visual design that are important?
Contrasting colors, so that colors don't look like the same color, look muddy.
Absolutely, right? So make sure you're using contrasting colors. Again, this idea of making things simple on the user. We're going to spend a bit of time when we get to visual design focusing on this particular design philosophy, which is in visual design, maximize the data to ink ratio. What does that mean? That means we want to try and present to the user as much data as possible, but use as little ink as possible. So I like the Gapminder example because I think it's a great exemplar of this idea. If you pay attention to any single colored pixel in this picture, it's doing some work for you. It's hard to find a little image, a little icon, or a piece of text that is extraneous on this image, right? Everything is working here to try and communicate as much data to you as possible in as visually simple a way as possible. Minimize ornamentation, which again goes against the medieval tradition, Western medieval tradition in art, which was to maximize ornamentation. The image on the right might look beautiful to some people. I don't want too much visual clutter when I'm trying to understand the relationship between health and wealth in countries. Question?
I feel like that transition was parallel, like in the development of the internet, like how you're saying that Alta Vista used to be like super cluttered with like moving images everywhere.
Absolutely.
And Google's start days, which is nothing.
That's right. If you go back in the Internet Archive and look at early web pages pre-Google, they tended to maximize ornamentation. Google was the first site that said minimize ornamentation, and today that's kind of become the standard, right? If you want to look at something beautiful, look at a work of art. If I'm looking at a web page, it's usually because I'm trying to get something done, right? Don't distract me. For those that are creating visual interfaces, there is always a temptation to add ornamentation, right? A temptation to focus on what the technology can do, right? This drawing package has animations. I'm going to put some animations in my visual display. You can, but does that necessarily mean you should? Okay. Okay, I think this is a great example. Let me see if I can find a way to restart this. I guess it's just going to run on its own, so we'll just let it wrap around. Kind of a pedestrian example here of a spreadsheet, and we'll let it wrap around. What you're watching in this animated GIF is a whole bunch of rules of thumb about how to minimize ornamentation. In this, here we go. Okay, so here's the beginning. And as we'll see in a moment, a standard spreadsheet providing very important information about pro wrestlers. Take away the back color, and we're going to remove the colors first, remove grid lines, remove fills, and so on. So this whole animation is removing things, not necessarily adding things. And we don't have time today, but go watch this animated GIF a few times, and it's amazing how clear it is at the end compared to how it is in the beginning. Right? So again, we may not all be super focused on creating beautiful spreadsheets, but it's amazing if you pay attention to visual design, how much you can remove. And by removing things, you're only removing extraneous things and helping the user focus on whatever they want to know about pro wrestlers back in whatever. Okay. There you go. Less is more. Very important principle in HCI. We've got 2 minutes left. Let's look at one last example. Architecture is a great exemplar for HCI because like HCI, architects have to balance subjectivity and objectivity, right? We want to try and create buildings that inside and outside are beautiful, but they also have to be functional. So the moment we mention that they also have to be functional, we have to start thinking about constraints. We can't do everything with a building. What are some constraints that exist in architecture?
Cost.
Cost, okay, that's an important constraint.
Physics.
Physics, okay. Let's be specific to architecture, buildings.
Legal building codes.
Legal building codes, right? Those make those constraints explicit. What are some of those constraints? Support beams, that's important.
Human beings like to live in
boxes.
Human beings like to live in boxes, at least that's what architects think, right? So in most buildings, there's a clear separation between floor, walls, and ceiling. So that is a constraint. Is that a hard and fast rule? Maybe yes, maybe no. I'll leave things there for you to think about. You have a quiz due tonight. Deliverable 2 and deliverable 3 are due not this coming Monday, but the following Monday. See you on Tuesday.